Okay guys, so lesson 6.5, what we're doing is we're looking at financial applications and how we can use exponentials to model those. So what we're doing here, guys, is we're first filling out this chart. It says the cost of living is affected by inflation. So each year you'll see that prices will go up. So we're investing $1,000 and we're paying more than 2% interest. So it's going to be paying more than 2% interest if we invest our money. So the financial advisor presents us with a 3% per A, which means per year, that you're earning this interest. The compound interest is calculated at the end of each year at this rate. So compound interest just means that you're getting interest upon interest, right? So that's good when you are getting investments, but it's bad if you owe money. So credit cards will be compound interest. So in year 0, our starting value is $1,000. After year 1, if we invest it with 3%, what that's going to do is it's going to say, well, we started off with $1,000, but then what we're going to do is we're going to add 3% of $1,000. So $1,000 times 0.03. So always when it comes to percentages, you want to divide that number by 100, and that's how you get the interest rate. Okay, so here we are multiplying by 0.03, and we're adding that to the initial 1,000, which gives us that by the end of the first year, we're going to have $1,030 in our account. Now, our starting amount for the next year will be $1,030. Again, we're going to add interest to this amount that we have. So $1,030, we're going to multiply that by 0.03. So that's what compound interest is interest on the new amount. So that's going to give us actually $1,060.90. So our money is growing. Our starting value in year 3 would be $1,060.90. Okay, so $1,060.90, and we're getting interest on that amount. So write that amount out, multiplied by the interest rate. And that's going to give us, by the end of the third year, $1,092.73. So this is what compound interest looks like. So we're going to be using a formula for compound interest. So P represents your principal starting amount, I is your interest rate, N is how many periods you're going to be getting interest for, and your A of N is your future value. So how many years will it take for Arthur's $1,000 to double in value if you're at 3% interest per year? So our P, our principal, is $1,000. Our interest will be 0.03. Okay, and it says we want our value to double, so our A of N, meaning our final amount, is going to have to be $2,000. So we're going to plug these values into our new equation and then solve for your N, meaning how many years it will take. So 2,000 is equal to 1,000, 1 plus 0.03 to the power of N. So we're going to start by putting this into our calculator. So this is going to be our Y1, and this right side is going to be our Y2. So place that into your calculator. So 1 plus 0.03 will be 1.03 to the power of X. So this is how we're placing it into our calculator. So Y1 is the left side, Y2 is your right side. Now you're going to use a window that makes sense. X represents the amount of time that it's going to take for your money to double. So I would say from, as an estimation, 0 to 50 years. And for Y, we need to be able to see the $2,000 that we're going to get by the end of it. So we're going to go from 0 to $3,000, just slightly over the 2,000 mark. When you graph it, you should see an intersection. So what you want to do is find the intersection by doing second trace number 5, move your cursor as close as possible to the intersection, and then press enter 3 times. So that's going to be 23.45, which is going to round up to 24 years. So here we're pressing second trace number 5, the intersection. And when you press enter 3 times, you're going to get approximately that n is equal to 24 years. So example number 1, Brittany invests $2,500 into an account and she pays 3.5% per year, but this is going to be compounded monthly. So she's going to get interest per month. So what we want to do is we want to use the equation again, but there's going to be a slight difference to this answer here. So we're still using the same equation. This is going to be our P, our principal amount. This is going to be our I, but there's a trick to this. First, we're going to have to divide this by 100. So 3.5 divided by 100 is going to be 0.035. But we're also going to have to figure out how much interest we're going to get if we're getting interest per month. So you're going to have to divide this number by 12 because there's 12 months in a year. So if you divide by 12, your actual I value will be 0.0029. So this is when you divide your yearly interest by 12. Okay, so once you have that done, it says determine the interest function that models this equation. Pretty much just fill in your numbers into the equation. So A of n, we're solving for sometimes, depending on what the question gives us, but we should leave that blank. Principal, you're going to fill in $2,500. 1 plus your 0.0029 value to the power of n. And the only thing I'll do for A is just simplify what's inside the brackets. So by adding those numbers together, this is the function. So that's what a function looks like. A function is where you have your y coordinate and your x value. So in this case, n is our x and A of n is our y coordinate. So they want to know how long in months will it take for Brittany's investment to grow to $3,000. Well, this is your A of n. So we want $3,000 to be replacing A of n, and then everything else stays the same. So this will be your y1, this will be your y2. We're going to find the intersection between the two equations. So go to your graphing calculator. So we have $3,000 going here into our y1. And then we started with 2,500, and then we have 1.0029 to the power of x. So our window, we're figuring out how long it will take in months for our investment to reach a certain value. So we're going to go from 0 to maybe 100 months. So I'm estimating a little slightly higher than what I think the answer could be, just so I don't miss it. And then we're trying to get our value to be $3,000. So I just have to pick two values around 3,000. So I'm going to pick from 0 to 4,000 because 3,000 would be in between there. Graph it and you should see an intersection point. So now I'm going to go second trace, number 5. Move your cursor as close as possible to the intersection. Press enter 3 times. Okay, so what you should be finding is that the value, if you're doing correctly, mine's not working for now, but if you put into your calculator correctly, you should see that. I'll try once more. There it is. So it should be 62.961, which I would round to 63 months. So round up. So I'm rounding to, our n value would be 63 months. And that's our answer. Example number 2. It says, after Brittany's investment reaches $3,000, the bank changes the interest rate to be 3.5% per year. That's what the A stands for. Compounded semi-annually. Semi-annually means you're going to get interest twice a year, so 2 times per year. So we're going to reinvest. So that means that this is going to be her new principal. This, our I, is going to be, first you're going to take 3.5 divided by 100. And you'll get 0.035, but you're going to need to divide this answer by 2 because we're going to get interest twice a year. So our I value is going to be 0.0175. So let's write in our equation. We're going to have A of n is equal to $3,000, our principal, 1 point, because we're going to have to go 1 plus our interest, and that's going to be 1.0175 to the power of n. And n, we're going to have to figure out how many semi-annual periods this is. So this is in years, which is not what we can put into n. N needs to be semi-annual periods. So that means we're going to have to multiply this answer by 2 because we're getting interest twice per 1 year. So that means we're going to get interest 8 times throughout the 4 years. So this is what you would put into your calculator, right? So we're going to graph this. We're going to graph the original equation with n here, or in our case, x, and then we're going to solve for if there's 8 semi-annual periods. So go to your equation, clear whatever you have there. You're going to put 3,000. Then you're going to put your 1.0175 value to the power of x. We're going to change our window to be able to see these values. So we're going to go from your x being from 0 to, let's say, because this is going to be semi-annual period. So 0 to, let's try 50 semi-annual periods, just to make sure we can answer all the questions. And for y, we're going from 0 to, let's try 6,000, because eventually we're going to have to use, for b, a 5,000 value. So we just want to go around that. So we're just using this so we don't have to change our graph again and again and again. So once we graph it, it looks like this. With our graph, they're telling us that they want the 4-year mark. So the 8 is our semi-annual period. So you're going to press trace. So in your calculator, you're going to go trace x equals 8 and then enter. So trace x equals 8 and then enter. And you should get that the value is, the y coordinate is your answer, which is 3446.65 if you round to the nearest hundredth, which is cents when it comes to money. So we need to write that our answer is $3,446.65. That's our final answer. Now, when will our investment reach 5,000? So that's our A of n. So this is going to be our y1 or y1, y2, and these can reverse. Like this can be your y2 and it could be your y1. It doesn't really matter. So I'm going to put 5,000 into my equation as my y2 in my case. Graph it. We want to see the intersection by going second trace number 5. So whenever you put something into y2, you are looking for the intersection. Press enter 3 times. And you should get that it is equal to 29.4. So that means n is equal to 29.4, and this is semi-annual periods. Now lastly, we need to figure out the year. So we're going to take this answer and we're going to have to divide this answer by 2. So 29.4 divided by 2, that means it's going to take approximately 15 years if we round up for this investment to go from $3,000 to $5,000. So that's how we get those kind of questions. Example number 3, let's say we have a situation where we're losing money. This is called depreciation. So let's say we buy a car or we buy a house in Fort McMurray. In this case, we're losing money, so it's depreciating. The rate is 20%. We're losing value. So how we change our equation is it's going to look the same, except instead of going 1 plus I, we're going to go 1 minus I to the power of n. So when we lose a value, it's going to be 1 subtract your interest. So we know that our principal amount that she bought this camera for will be $2,000. So she started after 2 years, the camera was worth $2,000. So that's the only amount we have. So we're going to write that down as our principal. 1 minus, we're going to take our depreciation rate and we're going to divide it by 100. So that's going to be 0.2. So that's going to be 0.2 to the power of n. And we want to figure out when this camera is going to be $200, worth $200. So this is our A of n value. Okay, so once we have that, we can simplify the equation, or we can just put this directly into our calculator. That's our y1. This can be our y2. And we're going to graph and find the intersection. So we have $200, and then we start off with 2,000 after 2 years. 1 minus 0.2 to the power of x. Change your window. Well, our x value, we're going to say how many years is it going to take? Well, maybe it'll take up to 20 years. Let's see. You can always adjust it if you don't see the intersection. And for your y, we know that it has to go from 0 to, it's going to have to go to $200, from $2,000 to $200. So as long as you can see $200 in here, I'm going to go from 0 to $300, just slightly over. Graph it, and then you should see an intersection. Now you press second trace, number 5. Go as close to the intersection as you can. Press enter 3 times. So the intersection will be 10.3 years. Now, the only thing we have to change is we need to adjust this. It says how many years will it take for it to be worth from when we bought it. So we're going to have to add 2, because remember, after 2 years, that's when the camera was worth $2,000. So from the time she bought it, it's actually been 12.3 years, which means approximately 13 years if we round it up. Okay, so that would be how you do those kind of depreciation questions. But there was a little trick at the end because they were only telling us the principal value after 2 years. So we had to use that and then just add the 2 at the very end. Our last type of question is they're giving us an equation where it will help us figure out how she's going to repay a loan. So Jessica borrowed $7,500 to the bank to buy new equipment, and we know the interest rate and we know the the monthly payment. So we need to figure out how many months it's going to take for her to repay the loan. So this equation right here, they're giving us a left side and a right side. So this is going to be our y1. The right side is going to be our y2. We're going to graph it and find the intersection. So we're going to write the equation exactly how we see it, but the left side goes into y1, so 1.003, close your bracket, to the power of negative x. And then your y value, y2 value, will be the 0.94 0.375. Now adjust your window. We're figuring out how many months it's going to take. So I'm going to go from 0 to, let's say, 50 months. So I usually use those kind of values. And then for y, we have to be able to see the graph when it's 0.94375. So I'm going to go from 0 to 1. Because 0.94375 is between 0 and 1. And we're going to change the scale to be smaller because we want it to cut the number from 0 to 1 in parts. So when I graph it, I can see an intersection between my graphs. You're going to go second trace number 5. Move your cursor as close as possible to the intersection. Press enter 3 times. You should get that it is about 19.07 in my case. Now we're going to have to round up to about 20 months. Okay, so from this value, so we found the intersection, and the intersection gave us like this 19 point, depends on your calculator and how you do it, but you could have 19.33, so that would be okay, but you just have to round up because we don't want to round down because we would then still owe money to the bank. So it has to be 20 months. So if it takes 20 months to repay the loan, how much does Jessica pay off? Well, 20 months times her monthly payment, which we know is $400. So if we multiply those two numbers, we know that she paid $8,000 to the bank. Now the total interest is how much extra did she give to the bank? Well, how much money did she give to the bank? Well, she gave $8,000 minus what she actually borrowed was $7,500. That means she gave the bank $500, and that's your interest. Okay, so that's the extra amount that you're giving the bank just for lending you the money. Okay, so what you need to know from this lesson is how to use this equation. And then if it's increasing, you use this equation, but if it's decreasing, you use 1 minus I to the power of n. And then if they ever say compounded, semi-annually, quarterly, then you want to use these numbers to divide your interest with. Okay, so if they say monthly, divide by 12, quarterly, divide by 4, etc. Okay, so that is your lesson.